Welcome to channel Qtomation. Today we will see one more topic, that is test cases design techniques. In test cases design techniques, we will see what is equivalence class partitioning. But before that, let's understand what is test cases design techniques and why they are used. Test cases design techniques are methods used to prepare the test cases with different type of test data and scenarios to ensure that software is thoroughly tested. These techniques helps in creating a structured and efficient testing process. Since exhaustive testing is not possible, testing techniques help to reduce the number of test cases to be executed while increasing the test coverage. As a tester, we should cover as many test cases around those scenarios. So whatever scenarios we are given, we should always cover all the different scenarios around that new feature or any new changes which are made in the software. But sometimes there could be some scenarios where exhaustive testing is not possible. There can be large number of test cases around those scenarios. In such situation, we have to use some design techniques of test cases. So there are multiple ways to design the test cases for such scenarios. We will see one by one in coming session about all the different type of test cases design techniques. There are mainly two types of test design techniques: white box testing techniques and black box test design techniques. As the name suggests, white box testing technique. Who conducts the white box testing? Normally, white box testing is done by developers. So we will not focus much on white box testing techniques, but we will see black box testing techniques in detail. But let's on a high level understand what exactly are white box test cases design techniques. These techniques involves testing the internal structures or working of an application as opposed to its functionality. So we don't directly test the functionality in the white box testing technique. We basically check the application on code level. In black box testing, we actually perform the functional testing on that new feature or new software. But in white box testing, it involves testing the internal structure of the application, and it is normally conducted by developers as a part of white box testing. So what are the different techniques developer uses in white box testing technique? Statement coverage. So whenever developer writes the code, he makes sure that every statement in the code is executed at least once. So he writes the test in such a way that it ensures that every statement in the code is executed at least once. Branch coverage. Branch coverage will ensure that every branch, that is decision point like if else statement, etc., are well tested. Path coverage. Path coverage will ensure that every possible path through a given part of the code is executed. Conditional coverage. It will ensure that each condition in a decision is tested with both true and false outcomes. So these are some white box test design techniques, and it is normally conducted by developers. So we are not going to see this in details. We just have to understand on a high level. But what we are going to see in details is, as a tester, we should always know what are the different types of black box testing techniques. So what are the different type of black box testing technique? Boundary value analysis, equivalence class partitioning, decision table, state transition, and error guessing. These are the different type of black box test design techniques. So out of these five, we will first see about equivalence class partitioning. So what exactly is equivalence class partitioning, or we can also call it as ECP? It allows you to divide set of test conditions into a partition or classes which should be considered the same. ECP testing method is dividing the input domain of a program into classes of data from which test cases should be designed. So we will see one example. In that example, we will understand in better way. So just understand. So basically, if there is such scenario where there are multiple type of test data or large amount of test cases need to be selected. So what we do is we basically divide the classes on some specific values, and after dividing that, from each class or each set of input data we consider one or two values only that will represent that entire class or entire group of test inputs. So it reduces the test data basically. So instead of testing for all the numbers, we will test only for the one or two representative of that class. The concept behind this test case design technique is the test case of representative value of each class is equal to the test of any other value of the same class. So normally if that specific test data or the test case works for that specific number of the class, then it should work for all the members of that class, and it allows you to identify valid as well as invalid equivalence classes. So we divide the classes on the basis of valid classes or valid inputs and invalid inputs. As a tester, we have to test all the positive scenarios that covers the positive inputs of a test data, and along with that we should always test on invalid input as well. So invalid input data also we can get it from specific class of the test data. Now we will see one example, then we will understand in better way. Now let's take one example, one real time example about setting a temperature in thermostat device. Now let's take one device in which we can set the temperature, but that device allows the temperature setting only between 6 degree and 10 degree Celsius. Now this is the condition. So by default, that device only allows the temperature setting between 6 degrees Celsius and 10 degrees Celsius. Means we can only enter the values 6, 7, 8, 9 and 10. From 6 to 10, only those values are accepted. Those values can be set in that device. And let's say if you want to test out that device, so what we have to do? So let's say you will test it for 6 degree Celsius, 7 degree, 8 degree, 9 degree, 10 degree. But what about below 6? So again there will be 5 degree, 4 degree, 3 degree, 2 degree, 1 degree, 0 degree and even negative values as well. What about after 10? 11, 12, 13, 14 and there is no limit on that. So if you see, there is lots of test input data are available. So as a tester, are you going to test for all those inputs? Is it possible practically? No, because if you are going to test for each and every value, each and every number, that it is not a practically feasible, right? So it is not a right approach. It will consume lots of time and it is not a logical solution of this problem. So in such situation, what we have to do? We have to make sure, so basically we have to make sure that the test data which we are picking, the test values we are going to test, that should cover all the cases, that means valid inputs as well as invalid inputs. So if you pick the test data in such a manner that will cover the positive as well as negative inputs, then with the minimum amount of test data, we can test out these scenarios. So between 6 to 10, if you take any value, let's say 9 degree, so it will work for 9 degree, then it will work for 8 degree, 7 degree, 6 degree and 10 degree as well, because that is between 6 to 10. So we can take one value between 6 to 10, that will create a positive class. And we can also take some values from negative inputs. So we can create some equivalent classes. So for such test condition, we can create equivalence classes. So that is called as a equivalence class partitioning. So instead of testing for all the test data, we will logically divide those test data into test classes. So for this example, which type of equivalence partitioning we can do? So 6 to 10 is a valid one, because that device will accept 6 degree to 10 degree. So any value from 6 to 10 are valid values. So this is one partition. Below 6, there is another partition. So below 6 all are invalid classes. So below 6, whatever value you are going to enter, that would be considered as a negative test input, because it is from invalid class input. Our device is going to handle only between 6 to 10. That is one class. One class which we have created for below 6 values, that is again invalid class. And one set of class we can divide after 10 values. So the values more than 10, greater than 10 degree, that means 11, 12, 13, 14, etc. So on. That will comes under third partition, that is invalid class, right? So how many classes we have created here? Three type of classes we have created, and each class will contain multiple values. So as a tester, we don't have to test for all the values. We can pick one or two values from one of the classes. From each class, we can pick one or two values. So what we can do? We will create one, we have created the classes. Then we can pick the sample values from each class. So for temperature less than 6 degree, temperature from 6 to 10 degree, and temperature more than 10 degree. So these are the three classes which we have created. And now logically we will just pick one or two values from each class. So for valid class, we can pick the value as 7 degrees Celsius and 9 degrees Celsius. So if it works for 7 degree and 9 degree, that means it will eventually work for 6 degree and 10 degree as well. Any value between 6 to 10, it will work for them. From invalid class, we can take one value, let's say 5 degrees Celsius. So if it is working for 5 degree, that means whatever behavior which we have given for invalid classes, that should work for 5 degree, 4, 3, 2, 0, any value less than 6. And another class is 11 to 14, greater than 10. So we can also pick one value from invalid class which is greater than 10, that is 11 degrees Celsius. So how many test data we require here? 4 type of test data. So that is the main benefit of equivalence class partitioning. You don't have to test for all the values. You can just pick one or two values from each class. And if you test it for that value, then that means it will work for all the other values from that specific class, whether it is a valid class or invalid class. So for valid class, we will get the valid behavior, and for invalid class value, we will get some invalid behavior, which is expected again, because we have seen already that even if the input is negative, there should be some handling. Either it would be an error message or some type of an informative message. So handling will be always there. So we have to verify that behavior. So this is the concept of equivalence class partitioning. So equivalence, what are the benefits of ECP technique? ECP means equivalence class partitioning technique. It is an effective black box testing method for creating the test cases. So during testing any software, you can get multiple scenarios where you will find similar scenarios like this one. So there would be a situation in your software testing where you will find such scenarios very often. So in such cases, what we have to do? We have to think on it, divide the test input into logical classes, which will consider valid inputs as well as invalid inputs. And from each class, we have to pick one or two values as a test data. It will focuses more on testing software functionality. It will increase the test coverage with reducing the number of test cases. So it will reduce the number of test cases while maintaining the test coverage as well. It will improve the quality and reduces the effort by creating the partitions. So main benefit of creating the partition is it will save the time. At the same time, with minimal amount of test data, we can cover all the scenarios. We can also maintain the coverage of our test cases. And also effort will be reduced. It will also save the time and it will simplify the work with generic test cases for each partition. It is normally useful for scenarios with a large number of test cases. It will ensure comprehensive test coverage and it will also test valid as well as invalid inputs properly. And whatever the expected behavior mentioned against those valid and invalid inputs, that would get verified because of this test data. So this is the main benefit of equivalence class partitioning. Now we have seen one example. Now let's say we can see couple of more examples around equivalence class partitioning. It will help you to understand in much better way. So let's say some more scenarios which can be solved by using equivalence class partitioning technique. So what are such scenarios? Now let's take an example of salary range. Now let's take a system, or let's say whatever software we are testing, that accepts a salary input in the range of $30,000 to $1,20,000. So our software or system accepts a salary input in the range of $30,000 to $1,20,000. So this is the range which is given, which is supported. This is the accepted range, and we have to test out that system for different type of salary amount. So what we will do here? So we will use equivalence class partitioning technique. We have just seen one of the example. Now let's understand how we will divide the classes. Again, what is the valid class we will divide? From 30,000 to 1,20,000 is valid equivalence class. What is the invalid equivalence classes? Less than 30,000 and more than 1,20,000. So this is one class and this is again one class. These are the invalid equivalence classes. So we got the three classes now. We have divided the test data into three classes. And now what is the next step? We have to pick one value from each class. So for valid class, we will pick one random value, let's say 50,000, which comes in between 30,000 and 1,20,000. So that is one valid class value. We will take one invalid class value. So less than 30,000, we will take 29,999. So this is the value for invalid class, which is less than 30,000. Another value we can pick from greater than 1,20,000 value. So 1,20,000 and $1. So that is greater than 1,20,000. So this is the value from third equivalence class. So by using these three test data, it will verify all the three classes. So you don't have to test for all the different amounts. You can just test it out for these three type of test data. So for valid class value, it should work as expected in a positive manner. And for invalid class values, it will give you some error, or it will give you the behavior which is expected for invalid values. So this is one of the example of equivalence class partitioning. Let's say one more example related to dates. Now let's say we have one application which allows a date to be entered, and the valid range is from 1 January 2000 to December 31, 2020. So this is the range which is a valid range. Now How you will divide this into a equivalent classes? So first is range is valid class range, that is dates between 1 January 2000 and December 31, 2020. All those days will be in valid equivalence class, and we will create one invalid class for dates before January 1, 2000, and another class will be dates after December 31st, 2020. So three classes we have. And what is the next step? We have to pick one value from each class. So for valid class, we can pick one value. For invalid classes also, we can pick one value. And we can test it out, our test cases, with these three values, which will eventually cover all the three classes for valid class as well as invalid class. Let's say one more example about shopping cart. So let's say we have one e-commerce application. In that e-commerce application, it allows the user to add items between 1 to 50 in a product. So what is the range here? Valid range is, quantity is 1 to 50. 1 to 50 is allowed. So first class, what is the first class? Valid equivalence class will be, first valid class will be 1 to 50. What is the next invalid class? Less than 1 and greater than 50. These two classes for invalid test data input. So again we have three classes here. Quantity equal to 10 for valid class. Less than 1, that means quantity can be 0, invalid class, and quantity more than 50, so 51. So we can pick any three values from such classes. And if you test that software with this three test data, then eventually it will work for all the values of those classes. So this is again another example of equivalence class partitioning. So I hope you are understanding the concept behind it. So in your real-time testing, you can get similar scenarios. So at that time, we have to think in a proper manner how to divide the test data into correct classes, and then we have to pick one or two value from each class. That is the main concept and test design technique, which is called as equivalence class partitioning. So that's about ECP technique, that is equivalence class partitioning. Thank you for watching this video. In coming session, we will see next type of test design technique, black box test design technique. So we are going to focus on black box test design techniques. So this is the equivalence class partitioning. Thank you for watching this video.